Dear students, today we will be studying about the application of Gauss law. The application of Gauss law, we calculate the electric field intensity at any point due to the different distribution of charge. We had studied about the electric field intensity due to a uniformly charged infinity length conductor wire. Today we study about electric field intensity due to a uniformly charged spherical shell. Consider a spherical shape of center O and radius capital R. We calculate the electric field intensity set up by the spherical shell at the point P of distance R from the center of sphere. कोई पॉइंट P है जहां आपको जो है इस पूरे स्फेरिकल शेल के रीजन से जो है आपको इलेक्ट्रिक फील्ड इंटेंसिटी फाइंड करना है. When the sum amount of charge plus Q give the conductor spherical shell, the charge uniformly spread throughout the surface of the conductor shell. जैसे ही इसको आप कोई चार्ज देंगे तो ये चार्ज इसके पूरे सरफेस पर यूनिफॉर्मली डिस्ट्रीब्यूट हो जाएगा. ठीक. The intensity of field due to a uniformly charged spherical shell at the point P. यहाँ पर एकदम सिंपल दिखाई दे रहा है कि the point P lies from the outside of spherical shell. यानी कि फर्स्ट केस कि when the point P outside from the shell. In case capital small r is greater than capital R. अगर ये पॉइंट P जो है शेल के बाहर होगा तो इस कंडीशन में स्मॉल r इज ग्रेटर देन कैपिटल R. First, we draw an imaginary surface of radius small r which passing through from the point P is called Gaussian surface. सबसे पहले आप एक इमेजिनरी सरफेस ड्रा करोगे जो पॉइंट P से पास करेगा और इसका रेडियस जो है R होगा. द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू द uniformly charged spherical shell is perpendicular from away to the infinity by symmetrical. ये इसकी सिमेट्रिकल प्रॉपर्टी होती है कि जो इससे इलेक्ट्रिक फील्ड सेटअप होगा उसका डायरेक्शन जो होगा परपेंडिकुलर जो होगा away to the infinity. We taken a small area element at the point P of area vector dA. First, the electric flux passes through the area element d phi e is equal to e into dA cos theta. We know theta is the angle between vector E and vector dA. dA, where theta is equal to 0 and cos 0 is equal to 1. Vector E parallel vector dA. Then d phi E is equal to E into dA. Then the total electric flux through passage the Gaussian surface. Closed integration d phi E is equal to closed integration E into dA with respect dA. We know closed integration dA is equal to A is equal to 4 pi r square, where 4 pi r square is the area of Gaussian surface. Then phi E is equal to E into 4 pi r square. Taken equation 1. According to Gauss law, phi E is equal to Q by epsilon naught. Taken equation 2. The students, the total electric flux passing through a imaginary surface is equal to the 1 upon epsilon naught part of total enclosed surface by imaginary surface. तो ये टोटल चार्ज जो होगा अगर इस स्फीयर से इंक्लोज होगा तो इस बड़े वाले स्फीयर से भी इंक्लोज होगा. तो ना if I E is equal to Q by epsilon naught. Compare the equation. Compare the equation 1 and 2. We get E into 4 pi r square is equal to Q by epsilon naught, or E is equal to 1 upon 4 pi epsilon naught into Q by r square. It is electric field intensity due to the uniformly charged spherical shell at the any point P which lies in the outside. मतलब ये किसी भी पॉइंट के लिए हो सकता है. आप यहाँ पर भी ये पॉइंट P ले सकते हो, यहाँ पर भी ले सकते हो, यहाँ पर भी किसी भी पॉइंट P पर जो होगा, लेकिन वो पॉइंट P उसके आउटसाइड हो, वहाँ पर इंटेंसिटी जो होती है E is equal to 1 upon 4 pi epsilon naught into Q by r square. We had proved the electric field intensity due to a point charge. पॉइंट चार्ज के लिए भी हम लोगों ने फाइंड किया था कि E is equal to 1 upon 4 pi epsilon naught into Q by r square. So we said the electric field intensity at any point outside of the uniformly charged spherical shell is same like behave as the total charge of conductor shell is concentrated at its center. इसका बिहेवियर जो ऐसे होता है कि इसका टोटल चार्ज जो है इसके सरफेस पर नॉट डिस्ट्रीब्यूट होकर जो है इसके सेंटर पर क्या कर रहा है, कंसंट्रेट हो रहा है. Second condition. Second, when the point P point P lies at the surface of conductor say in this case we shall assume the point P is separate at the surface of a spherical cell. In this case capital R is equal to small r, and put the value of small r, we get E is equal to 1 upon 4 pi epsilon naught into Q by capital R square. It is electric field intensity due to the uniformly charged spherical shell at the surface. We know small sigma is equal to Q by A, where small sigma is the surface density of charge, and A is the area of surface, area of shape. Then Q is equal to small sigma into A. Small sigma into A. Put the value. E is equal to 1 upon 4 pi epsilon naught into small into sigma into A upon R square, where A is equal to 4 pi R square. Put the value of 4 pi R square. Then E is equal to 1 upon 4 pi epsilon naught into small sigma into 4 pi R square upon R square. 4 pi cancel and R square sir. E is equal to small sigma upon epsilon naught. This is second formula of the electric field intensity set up by the uniformly charged conductor shell at the surface. In third condition, when the point P lies inside of the conductor shell, अगर आप सपोज किया जाए कि ये पॉइंट P जो है सेल के अंदर है, ठीक है, तो सेम लाइक we draw an imaginary surface of radius small r passing through from the point P. फिर वैसे ही आप एक imaginary surface ड्रा करेंगे और taken the area element of area vector dA as the electric field and vector dA parallel each other. Then according to Gauss theorem, phi E is equal to closed integration E into dA is equal to Q by epsilon naught. Simple is it? We know the total amount of charge of a conductor is uniformly spread throughout the surface of conductor. उसका जो टोटल चार्ज होता है वो उस पर यूनिफॉर्मली स्प्रेड होता है, यानी कि we say कि no any amount of charge enclosed by the conductor से. तो जब कोई चार्ज इससे जो है इनसा इंक्लूड नहीं होगा, then the total electric flux becomes 0. Okay, then closed integration E into dA is equal to 0 or E is equal to 0. जब कोई भी चार्ज इसे इंक्लूड नहीं होगा तो Q की वैल्यू 0 हो जाएगा और इस कंडीशन में E इंटू डी ए इक्वल टू 0 और E इक्वल टू 0। आज वी से कि द इलेक्ट्रिक फील्ड इंटेंसिटी एट एनी पॉइंट inside of the informally conductor spherical cell is 0। नहीं, किसी भी कंडक्टर सेल के अंदर जो होता है इलेक्ट्रिक फील्ड 0 होता है और उसके आउटसाइड जो है एट एवरी पॉइंट इज कांस्टेंट आर सेम।